In section 3 of chapter 3, we're going to be graphing linear functions. So, we start off with our objectives. Graph linear functions. Graph linear functions by using the intercepts. And then we'll graph vertical and horizontal lines. Now, we've done some of this already, so this will, to a degree, be a review. So we start back in section 1 of chapter 3 with this equation. Y equals 2x. Well, remember, this is in the form y equals mx plus b, which is the slope-intercept form. And if we put some values, these are the traditional t-chart here, 1, 0, and negative 1, and you put the values there for x, you get these. And if you made a graph by plotting the points, you get this. Now, notice up here there isn't a value for b. And we're saying that b is the y-intercept. That's where this will cross the y-axis. Well, there isn't one because our y-intercept is 0. It's going right through the origin, and we don't write it. Okay, we'll pick up on a few other things as we go on. So we had the equation y equals 2x. Now they're introducing a similar, and it's in function form though, y equals 2x plus 1. Now when we plot the first one, that's this line here, when we plot the second one, notice what happens. The graph shifts up 1 unit. So now our y-intercept is at a positive 1, right there. Now in example 2, they want us to graph a negative 3x and then later a negative 3x minus 6. And we'll do that using a t-chart. And notice what's happening now. For this one, our y-intercept is going to be 0, so it goes right through 0. But now in this one, our y-intercept is negative 6, and it drops down there to a negative 6. Now the slopes are the same, and we'll be working on that as well. So we've done some practice using the t-chart and getting points and plotting, but now we're going to look in more detail at what this idea of using the intercepts. Again, the intercepts are where the line crosses the axes. So when we write the formula of slope-intercept, y equals mx plus b, whatever is in this b position is the y-intercept. Now when we see this as an ordered pair, it's going to be 0, comma the value of b, because when x is 0, then you're on the y-axis. So here they just want us to find the y-intercept. Well, it's in slope-intercept form. Remember, we can substitute a y here, and our y-intercept is 3/7. Here, it's going to be a negative 3.2. We can do this one too. The y-intercept here is a negative 2/5, and here it is a positive 4.1. Now, we should mention something else. We're going to get to this very shortly. The letter m here, whatever the coefficient of the x is, this is the slope of the equation. We're going to do slope in our next section, but we can mention it here. So what would the slope be here? Well, it would be 1/2. And here a negative 2.5. And here 3/4. And here 2.6. Now we have one of the intercepts, the y-intercept. We're looking how to get the x-intercept also. And I will show you that in the next page. Now for this, I like to use this little thing called the x and y intercept t-chart. So this is a t-chart, and we put a 0 under the x here, and then next one down, a 0 under the y. Now for this value, it's going to be 0 comma b. Whatever we find for the y will be our b, our y-intercept, and this one will be a comma 0. That is, this value, once y is a 0, then this is going to be our x-intercept. Now a very typical equation, which is this one here in standard form. Now this t-chart works very well when the equation is in standard form. Why is that? Well, we'll see right now. So we're saying x is a 0 here. This x is a 0. So this becomes a 0. Now to find what y is, we divide both sides by 4, and we get y is a negative 3. Where x is 0, dividing both sides by 4. Now, for the x-intercept, we're going to make y a 0. So this becomes a 0. And now we divide both sides by 3. So this will be a negative 4. So we now have both of our intercepts. We'll see the graph in a moment. But plotting these then, it's pretty easy. 0, negative 3. 1, 2, 3. A dot right there. Now this is negative 4, 0. So 1, 2, 3, 4. A dot right there. And then it's just a matter of putting your line. It's off a little bit, but you see now we have plotted and found the x and the y intercepts. We use this little t-chart as a tool when it's in standard form, substituting in one case x a 0, and then later y is 0, and we get our y-intercept and our x-intercept. And there's the official graph of it. X-intercept, y-intercept. Now, in MathLab, they're going to ask you to find the intercepts and then make a graph of them. And in order to get credit for the answer, you have to have a dot at the x-intercept and a dot at the y-intercept. We're going to see other ways to graph, but when they're asking for the intercepts, you need to plot the intercepts. And we have time, so we'll do this practice example as well. So if x is 0 here, this is 0. 4 times 0 is 0. Now I'm going to divide both sides by a negative 5. Well, this will give me a 4. Now if y is 0, this is 0, 5 times 0 is 0, divide both sides by 4, this gives me a negative 5. So when I graph these, I get 0, 4, 1, 2, 3, 4, and then 1, 2, 3, 4, 5. There's my x-intercept here, and there's my y-intercept. And remember the form, 0b, that's your y-intercept, and a comma b, or 0 I should say, that's your x-intercept. Now, for example 5, they're giving us this equation. Let's put it in standard form. So x plus 2y equals 0. Now, if we were to make a t-chart, because they want us to find the intercepts, and this would be a 0 and this would be a 0. Well, if x is 0, then 2y equals 0. Dividing both sides by 2, this is 0. And if this is a 0, this is a 0. So when we set it up in standard form and there's a 0 in this position, this equation is going to go through the origin. So the x and y intercepts are the same. That is, it's going through the origin. So you need then one other point to solve this equation. So you need another point somewhere. So we'll say x is 2. So we have 2 plus 2y equals 0. 2y transpose the 2 is a negative 2. Divide both sides by 2, we get y is a negative 1. So we needed one other point. So we go over 2, and then we go down 1. And then this will be our equation here, or our graph. And you can see part of it. I'll move it up so you can see the whole thing. So that is like a special example when that term out there is a 0. Let me show you that one more time using this next one. So I'm just taking this equation, bringing my negative 3x over to the other side so it becomes positive. So when this is a 0 over here now, then it's going to go through the origin. So we need one other point. And we can use, let's say, a 1 here. So if x is 1, 3 times 1 is 3, and I'm just going to bring that 3 over to the other side and it becomes a negative 3. So for this one, the graph would be going through the origin and then going x is 1, y in this case is a negative 3. So the line would look like so. Okay, some more techniques for graphing. Now this has to do with graphing vertical lines and horizontal lines. We had said that in equation 5 on our little sheet there, that this was a special equation, y equals b. And we remember we said that sometimes the ordered pair is in this form, a comma b, which we said was x comma y. But here, this is an equation of a horizontal line. that goes through the y-intercept at this point. So if they said y equals 3, this would be a graph, 1, 2, 3, where you would put a dot there and a dot anywhere else, and this is what it would look like. Now for x equals a, and that's what they're showing us here, x equals 2, this is a graph of a vertical line, and a is our x value, which is going to be a 2. So a 2 there, and then a line going through 2. Now remember, there is an infinite number of points along all of these lines. That's what the arrows indicate. Okay, now we should mention in this case there is no x-intercept, and in this case there is no y-intercept. And there is the example y equals b. Remember, this is the y-intercept. So it's going to go through -3, and you just click on any other point along that horizontal line to make the graph. And for this one, y equals 4 would be a horizontal line through 4. Now there it is. They use the idea of x equals c. You see that in some books, but I like the idea of x equals a and y equals b. Remember, this is the form of the y-intercept, and this is the form of the x-intercept, a. So in some books it's a little different here. Now, which one of these equations represents a function? Well, this is a horizontal line, so this would be a function. This is a vertical line. This would not be a function. Now, if you have a graphing calculator, again, that would be useful for some of these, but we don't feature that here. And that would wind up section 3.3. This is in our textbook, a little review.